In this video we're going to talk about the idea of radian measurement. Now we're used to measuring angles in degrees, but there's a different unit of measurement that you'll often see used for measuring angles, and that is the idea of radians. So, definition-wise, angles can also be measured in radians. To define a radian, we're going to consider a circle with radius r centered at the origin as shown. I'm going to draw some things in here as we talk about it. So, here I have a circle, and I'm going to say that it has a radius of r units. So from the center, which is at the origin, out to the edge of the circle. Now, 1 radian is the measure of an angle in standard position whose terminal side intercepts an arc of length r. So what that means is, as I take r, my radius, if I were to take this radius and lay it around the outside of the circle, so that's what it's saying when it says it intercepts an arc of length r. So if I take this and kind of estimate about where that would be, because I understand I have to lay it around the outside circle, I'd say it probably would extend to about there. So that would be r units around the outside of the circle. Whatever the radius is, take the radius and lay it around the circle. We get something like that. Now, if I were to make an angle, whose initial side was here, and I put the terminal side intersecting that arc right there, that angle that I've just created, we'll call it theta. Theta would be equal to 1 radian. Measurement of an angle that intercepts an arc of length r is equal to 1 radian. So now if you're wondering about what that might be, it looks like it's about 60 degrees or so, and that's a pretty good estimate for what 1 radian might be. Now, as we think about how I might translate that into what I know about degrees, I want you to think about some other units that you know pretty well. I think you know that 3 feet equals 1 yard. You might know that 5,280 feet equals 1 mile. What we're going to do is we're going to figure out how many degrees does a radian actually equal. Well, think about this. The circumference of a circle is equal to, now one way you might have learned the circumference of a circle, I know I did, was pi times diameter. Well, another way that it's often taught is 2 times pi times the radius, or 2 pi r. So that's what we're going to use for a formula for the circumference of a circle, is 2 pi r. Now, if that's the case, that means that when I think about how many of these radii can I fit around the circle, there's 1, and there's 2, and there's 3, there's a little extra right here, 4, 5, 6, a little extra at the end once again. Well, how many of those can I fit? Well, I can fit 2 pi of them. 2 pi radii fit around the outside of the circle. And if that's the case, how many of these angles could I then have around my circle? Well, I can have 2 pi of them. So, 2 pi radians in a full circle. That means that 2 pi radians must be the same as 360 degrees. So 2 pi radians equals 360 degrees. Now, the other common formula that we'll see, use more common than this one, is if I were to divide both of these sides by 2, divide by 2, divide by 2, I know then that pi radians is equal to 180 degrees. And that would be the unit multiplier that we use to change from degrees to radians and vice versa. So, keeping that idea in mind, we'll look at a couple examples here. Converting between degrees and radians, there's a couple of unit multipliers. If I want to change degrees to radians, I multiply by pi radians over 180 degrees. And if I want to change radians to degrees, I multiply my expression by 180 degrees divided by pi radians. So, that being the case, and again, I think you've worked on some of this in the past, what we're going to do is we're going to change 75 degrees to radians first. Well, as I do this, again, thinking about changing feet to yards or something like that. Let's say I have 12 feet, and I want to change that into a number of yards. Well, I'm going to take 12 feet times a unit multiplier. The unit multiplier is matching up two expressions that I know are equivalent. Well, when it comes to feet and yards, I know that there's 1 yard for every 3 feet. Now notice I put the 1 yard on top and the 3 feet on bottom. The idea is that I want these units, the feet, to cancel, and I want to be left with a number of yards. So as I do this, feet cancels, yards is going to be the label, 12 times 1 is 12, divided by 3, well that's going to end up being 4 yards. Okay? I change my unit by multiplying by a unit multiplier. Another reason to think of it as a unit multiplier, besides the fact that we're using units of measurement, is that these two expressions being equivalent means I'm multiplying my original expression by 1. I'm not changing its value, I'm just changing its label, and that's it. So putting that idea to work here, if I want to change 75 degrees to radians, I'll use a unit multiplier. In this case, I need the degrees to cancel, so I will put the degree measurement on the bottom and the radian measurement on top. Now pi radians, if you want to write radians there, really we just leave things usually in terms of pi. So here's how this ends up working out. I get my degree label will cancel, and I'll have 75 pi over 180. And then what I'll do is I'll reduce this fraction as best as possible. Now for those of you who love using your calculator, this is how I would type this into my calculator. I know that my answer is going to have pi in the expression. So all I'm worried about is taking 75 divided by 180. I get a decimal, but we don't want decimals, we want fractions. So we change our decimal answer to a fraction. 5/12 is what I get. So what that means is that the answer I'd write here, instead of 75 pi over 180, I would write 5 pi over 12, or 5/12 of pi would be the better way to say this expression. So this is a number of radians based on the fact that 75 degrees is what I started with. Now if I was to go the other direction and change radians to degrees, well, I have a radian measurement, -5 pi over 4, and I need to change that to degrees. Well, that means I should have the radian measurement on the bottom and the degree measurement on the top. Now when you do this, you'll notice we're going to multiply top times top, bottom times bottom, but the nice thing is the pi part of the expression will cancel out because one's in the numerator, one's in the denominator. So then what I do is I take 5 times 180 divided by 4. Now again, for those of you who enjoy using your calculators, you just have to be careful with some parentheses. I'm going to take, in parentheses, -5 divided by 4, there's -5/4 times 180. And I get -225 for my answer. So I'm going to write that down. Remember, pi disappeared in the process, so we're going to have -225 degrees as our new measurement.